Today's video is going to be all about organic compounds. Organic compounds contain molecules that are found in all living things. It doesn't have to be living anymore, but if it was living at one point in time, it will contain organic compounds. All of these organic compounds have one element in common, and that is carbon. So all of our organic compounds, whether they be living or not living anymore, contain the element carbon. Now we're going to break up our organic compounds into a smaller group known as hydrocarbons. Hydrocarbons contain, surprise, hydrogen and carbon. We can break hydrocarbons up into 3 different groups depending upon the types of bonds that form. They're all going to be nonpolar covalent bonds, but we can determine if it's single, double, or triple bonds between carbons that will determine what type of hydrocarbon there is. So organic compounds are just a general term for molecules containing carbon. Hydrocarbons are a smaller group of that, which contain hydrogen and carbon. And then there are 3 different types of hydrocarbons depending on the bonds that form. Our first type of hydrocarbon is an alkane, and in an alkane, all carbon atoms are single bonded to each other. When you have CH4, there's only a choice of an alkane. With C3H8, you'd have 3 carbon atoms that are going to be in the middle, and they're all going to be single bonded to each other. We don't really care about the bonds to hydrogen because carbon to hydrogen bonds are always the same, but carbon-carbon bonds can change. So in C3H8, this would be the 3 carbons are all single bonded to each other. We also call these saturated, in which all carbons just have single bonds. That is the definition for saturated. All carbons have single bonds. Pretty simple definition. Our next type of group is the alkenes, in which you'd have 2 carbon atoms with a double bond. So C2H4, those 2 carbon atoms are going to have a double bond between them. C4H8, only 2 carbon atoms actually have a double bond. The rest of them are single bonded. So there's only 1 double bond in an alkene, at least the ones that we are going to look at. These are also considered unsaturated molecules because not all the carbon atoms have single bonds. There's going to be a double bond thrown in there somewhere. Our last group are the alkynes, and alkynes are when you have 2 carbon atoms triple bonded to each other. So C2H2, those 2 carbon atoms would be triple bonded, and then C5H8, once again only 2 of the 5 carbon atoms have a triple bond. The rest are single. Just like the alkenes, these are also unsaturated molecules. So alkenes have all single bonds and are saturated. Alkenes have a double bond and is unsaturated, and alkynes have a triple bond and is also unsaturated. If you're trying to figure out which bond goes with which type, they are in order. So alkanes would come first, and they have all single bonds. Alkenes would come next, and that has a double bond, and alkynes would come last, and that would be a triple bond. So they are in alphabetical order. So if we had to draw C4H10 and identify it as an alkane, alkene, or alkyne, our carbon atoms would all go in the center, and we know that they would have 4 valence electrons. 1, 2, 3, 4, and then there'd be another one here. So you'd have 4 on this carbon, 4 with that carbon, and then 4 with this carbon. And we know that they would bond here, they're going to bond right here, and right here. So we have 3 single bonds so far, and we have 10 hydrogens, and they're each going to come with 1 valence electron. So we have 1, and then another one here. We know hydrogens are always going to be on the outside, carbons are always going to be in the middle. So the easiest way to draw a hydrocarbon is to draw all of the carbons in a straight line and then start to put hydrogens around it. And so in this case, I have 10 hydrogens. They each come in with 1 valence electron, and then I have 4 carbons, which have 4 valence electrons each. So I can see that these are going to bond, these are going to bond, and we're always going to annihilate the dots. And so as I'm kind of connecting the dots here, I want to make sure that I have the total number of valence electrons correct, and that every hydrogen has 2, which it does. Every carbon has 8, which it does because it has 4 bonds, and that I have a total of 26 valence electrons, 16 from my 4 carbons and 10 from my hydrogen. So if I count, I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So I do have 26 valence electrons. So because these are all single bonded in here, I don't have to add any more bonds or anything like that, then this is going to be considered an alkane with the ANE. And there we go. C4H10. Doesn't even have to look at that pretty. So if we try to identify C6H12, that one is going to be an alkene because I'm going to have to draw that out with a double bond. So you can pause this and try to draw this out, make sure you can fit a double bond in there, and then you just adjust the hydrogens because there's many different ways to write these Lewis structures. So just change the hydrogens around so that you have 4 bonds to every carbon and just 1 bond to each hydrogen. Then if I were to draw C4H10, that's the one that I just drew out, so I knew that was an alkane because it had all single bonds. C2H6 is also going to be an alkane, so try to draw that one out and make sure that you get it as all single bonds in there. Something that contains triple bonds, we know is going to be an alkyne. Something that is saturated is going to be an alkane. Alkenes and alkynes are both unsaturated. So when we name these slightly different than we do covalent compounds. This has a completely unique set of naming rules. We still are going to do prefixes, but these prefixes are different. I will give you these for any test that you need. You don't have to memorize these, but the prefix is going to correspond to the number of carbon atoms. We said organic compounds are all about carbon, so we focus on the number of carbon atoms. So if I had 4 carbon atoms in my C4H10, then the prefix for that would be bute. Then if I had 10 carbon atoms, my prefix would be dec. 9 carbon atoms, non. So depending on how many carbon atoms you have, that's the prefix that you're going to pick out. The suffix is going to depend on the type of bonds that you have. If you have alkane, then it's all single bonds, so then your suffix is going to end in ane. If you have a double bond in there, that's going to be an alkene, so then your ending is going to be ene. And if you have a triple bond in there, it's going to be an alkyne, so you're going to have an ending of yne. So the prefix depends on the carbons, the suffix depends on the types of bonds involved. Ethane. Ethane means you have 2 carbon atoms, that'd be the eth, and a single bond in there, that's the ane, because it's an alkane. Heptyne. Hept means there are 7 carbon atoms in there, and yne means there's going to be a triple bond somewhere within 2 of those atoms. And some other ones that you might recognize a little bit more, like propane. So propane, prop means 3 carbon atoms, ane means it's all single bonds. Methane, which is the gas that we use for our Bunsen burners, it's natural gas. Meth means 1 carbon, ane means it's all single bond. Then there is a little additional part here with the carbons that can sometimes form a circle, and this doesn't happen too often, but it still does happen. And you have to be told that the carbons are connected in a circle, otherwise you would assume they are in a straight line. If the carbons are connected in a circle, then we're going to use cyclo before the prefix. So cyclohexane would mean that 6 carbons, so that's where the hex part comes in, are single bonded in a circle. The ane means a single bond, the cyclo means that they're going to be in a circle. So they do have different properties. If it just said hexane, then it would be 6 carbon atoms connected in a straight line with single bonds. But because of the cyclo part, we're going to connect it in a circle. So if we wanted to name C2H6, 2 means eth, and then the H6 means that this would be an alkane in all single bonds, and it's not connected in a circle. It has to tell you if it's connected in a circle, and you can't connect two in a circle anyway, so that wouldn't work. But this would be ethane. Then C3H4 would contain a triple bond, and 3 carbons means prop, so this would be propyne. So make sure you can draw that out and show a triple bond in there. Then if we wanted to name this structure, so I have 1, 2, 3, 4 carbon atoms, and I can see they're all single bonds in here. So that one would be, then that one would be butane, because there's single bonds and there's 4 carbon atoms. And then decane, dec means 10, ane means single bonds. So if I drew that out, I know that I would need 22 hydrogens, because every carbon has to have 4 bonds. So I just put as many hydrogens that I need to make sure that I have 4 bonds around each carbon. And ane means they're all single bonds. So the end carbons would need 3 hydrogens added to it, and then all of the inside carbons would just need 2 hydrogens added. So that's where I'm going to get C10H22. Then finally, pentene. Ene means there's a double bond in there. So pent means 5. So somewhere within those 5, I have to put a double bond. Doesn't matter if it's between the first and second carbon, second and third, third and fourth, whatever carbons you want to put that double bond in between. Then you just adjust the hydrogens around there, put in as many hydrogens as you need so that you have 4 bonds to every carbon. So when you're just given a name and you have to come up with a formula, you need to make sure that you have a correct structure. The name tells you what type of bonds you're going to have, and then the number of hydrogens will just depend on how many you need to add, because these are hydrocarbons, so the only other element that you can have in there is hydrogen. So you just put as many hydrogens as you need to make sure that every carbon has 4 bonds to it.